This question says, solve the following inequality. X minus 4 times x minus 5 times x minus 7 is greater than or equal to 0. Now this is what we call a polynomial inequality. And to solve a polynomial inequality, we need to find first the x-intercepts. So we're going to treat the function as if it had an equal sign instead of an inequality. So I'm replacing that inequality symbol with an equal to symbol to find the x-intercepts. Luckily, this polynomial is already factored. We're going to set each factor equal to 0. X minus 4 equals 0, x minus 5 equals 0, and x minus 7 equals 0. And when we solve, we'll get x equals 4, x equals 5, and x equals 7. We're going to take these values and put them on a real number line, making sure we go in order from smallest to largest. 4, 5, and 7. And what we want to do is test each one of these intervals. So we're going to pick test points in each interval. So I'll pick 0, 4.5, 6, and 8. So you're making sure you're picking a test point within that interval. And you want to take your test points, which are your x's, your test points, and you're going to substitute those test points of 0, 4.5, 6, and 8 into your polynomial expression, x minus 4 times x minus 5 times x minus 7. And what you're looking for is to tell whether this expression is positive or negative in that interval. So for the first test point of 0, we would have 0 minus 4 times 0 minus 5 times 0 minus 7. And that would be a negative times a negative times a negative, which is a negative. So that's telling me that I have a negative value for that expression in the first interval. So let me test 4.5. It's 4.5 minus 4, 4.5 minus 5, and 4.5 minus 7. So 4.5 minus 4 would be positive. 4.5 minus 5 would be negative. And 4.5 minus 7 would be negative. Positive times a negative will be a positive. So in this interval, our expression is positive. We'll test the next interval. 6 minus 4 times 6 minus 5 times 6 minus 7. 6 minus 4 is a positive. 6 minus 5 is a positive. And 6 minus 7 will be a negative. Positive times a negative is a negative. So in this interval, from 5 to 7, our expression is negative. For our last test point, we would have 8 minus 4 times 8 minus 5 times 8 minus 7. 8 minus 4 is a positive. 8 minus 5 is a positive. And 8 minus 7 is a positive. Positive times a positive times a positive is a positive. So our last interval will be a positive. And then we're going to look at our original inequality again. X minus 4 times x minus 5 times x minus 7 is greater than or equal to 0. So we've built this chart for us to see which intervals are positive, which intervals are negative, And also, because we found the x-intercepts, we found these points where the expression equals 0. So those x-intercepts are the points where the expression equals 0. And because our inequality says greater than or equal to 0, we want to choose the intervals that are positive. Positive is greater than 0. And we also want to choose the values that make the expression equal to 0 as a part of our solution. So our solution to that inequality will be the interval from 4 to 5. We're going to put brackets on 4 and 5. And then we'll also have the interval from 7 to infinity. And these are all the solutions to the inequality. This question says solve the inequality r of x is less than 0, where r of x is equal to x plus 4 over x times x plus 5 by using the graph of the function. So we're going to solve the inequality r of x is less than 0 using this picture. So first I want to distinguish between the pieces of this graph that are equal to 0, that are greater than 0, and less than 0. So we can use the x-axis. The x-axis is y equals 0. And any points that are on that x-axis will have a y-coordinate of 0. So that would be this point right here at -4. Then above the x-axis is where y is greater than 0. So here we have some pieces that are above the y-axis. And then the pieces of the graph where y is less than 0, those are the pieces that are below the x-axis. And these pieces of the graph here are below the x-axis. So what we notice is that our graph can change signs in certain places. It changes signs over a vertical asymptote. It changes signs over an x-intercept. And it changes signs over here over the vertical asymptote. That first vertical asymptote is occurring at x equals -5. That x-intercept is occurring at -4. The second vertical asymptote is occurring along our y-axis, which is an x value of 0. So what we're looking for in this example is r of x, our function, being less than 0. So we want to use those pieces that are below the x-axis. So that includes this section. This section goes from -infinity up to that vertical asymptote. That vertical asymptote is an undefined portion of the graph. And then we have this section of the graph being below the x-axis. That section starts at that x-intercept of -4 and ends at this vertical asymptote of 0. The vertical asymptote is an undefined portion, so we wouldn't want to include it. And the x-intercept we wouldn't include because we're only looking for where the function is less than 0, not equal to 0. So the solution to this inequality, r of x is less than 0, our x is from -infinity to -5, union with -4 to 0. In this example, we want to solve the inequality algebraically. So this type of inequality is a rational inequality. because I have a rational expression. And to solve the rational inequality, I want to find any x-intercepts. I can find the x-intercepts by setting the numerator equal to 0. If I subtract 5 on both sides, I get x equals -5. And then I also want to look for vertical asymptotes or holes in the graph. And we can get the vertical asymptote by setting the denominator equal to 0 and solving. And we get x equals 4. These are the values that we're going to include on our chart. So we're going to put -5 and 4 on our chart. We want to choose test points in each interval. So I'll choose -6, 0, and 5 for my test points. I want to take my x's or test points and substitute them into the rational expression. So my test points are -6, 0, and 5, and we'll substitute those into our rational expression, x plus 5 over x minus 4. And we're looking to see when that rational expression is going to be positive or negative. So substituting a -6 into the expression would give me -6 plus 5 over -6 minus 4. That's a negative over a negative, which is a positive. This example says solve the inequality algebraically. This type of inequality is a rational inequality because I have a rational expression on this side. To solve the rational inequality, I need to first find the x-intercepts. You're going to find the x-intercepts by setting the numerator equal to 0 and solving. So I'll subtract 5 on both sides and get x equals -5. Then I'm going to find the undefined values for the expression, or the vertical asymptote, by setting the denominator equal to 0 and solving. So I'm adding 4 to both sides. That gives me x equals 4. These are the values that I'm going to put on my chart. Make sure you put them in order from smallest to largest. Then we're going to choose test points in each interval. So I need to pick a test point that's less than -5, like -6. I need to pick a test point in between -5 and 4, like 0. And I need to pick a test point that's greater than 4, like 5. And then we're going to take those test points, or x values, and we're going to substitute them into the rational expression, x plus 5 over x minus 4. So our test points of -6, 0, and 4 will get substituted into the expression x plus 5 over x minus 4. And what we're looking for is to determine whether that rational expression comes out positive or negative in those intervals. So for the first test point, if we substitute it, we would get -6 plus 5 over -6 minus 4. -6 plus 5 is a negative, -6 minus 4 is a negative, and negative divided by a negative is a positive. So that first interval is a positive. Using the next test point, I'll substitute to get 0 plus 5 over 0 minus 4. 0 plus 5 is a positive, 0 minus 4 is a negative, a positive divided by a negative is a negative. So this next interval, the rational expression comes out negative in. Then our last test point of 4, I'll substitute that to get 4 plus 5 over, I substituted the wrong value. Okay, my test point is a 5, not a 4. So substituting my test point in of 5, I get 5 plus 5 over 5 minus 4. 5 plus 5 is a positive, 5 minus 4 is a positive, and a positive divided by a positive is a positive. So this last interval is a positive. The rational expression is a positive in that interval. Now then, going back to my original inequality, I was looking for that rational expression to be greater than 0. So I'm going to choose the intervals where my rational expression came out positive, which is greater than 0. So the interval notation for this first interval would be starting at negative infinity and then going to that x-intercept of negative 5. I'm going to put a parenthesis on that negative 5 because I don't want to include it. I'm only looking for where the expression is greater than 0, and negative 5 is a value where the expression equals 0. Then the other interval we'll include in the solution set starts at 4 and goes to infinity. And we'll also put a parenthesis on that 4, but for another reason. 4 is where the vertical asymptote would be, and our rational expression is undefined at that value. So to solve the inequality, x plus 5 over x minus 4 is greater than 0, we have a solution set of negative infinity to negative 5, union with 4 to infinity. This question says evaluate each expression using the graphs of y equals f of x and y equals g of x shown below. So this curve here is labeled with g of x, and this curve here is labeled with f of x. And we're asked to find g composed with f of negative 1, g composed with f of 0, f composed with g of negative 1, and f composed with g of 4. So let's start with part A, g composed with f of negative 1. So the operation of composition is substituting one function inside the other function. So g of x is the outside function and f of x is the inside function. And I want to substitute negative 1, the value in the parentheses here, into the inside function first. So I'm going to use the graph to figure out what f of negative 1 is. So I would go to an x value of negative 1, which is here, and I want to go up to the graph of f to get what f of that value is. F of negative 1 is 3. And now I can work out what g of 3 is. I'm going to go to an x value of 3, go up to the graph of g, and that y value is 2. So g of 3 is 2, and g composed with f of negative 1 is 2. Let's try another one. We have g composed with f of 0. The operation of composition is substituting one function inside of another function. G is our outside function, f is our inside function. So first I'm going to find f of 0. So I'm starting out at an x value of 0. I'm going to go up to the graph of f to get the y value, and that is a y value of 2. And now I can find g of 2. Here's an x value of 2. I want to go up to the graph of g, and I get a y value of 3. So g of 2 is 3, and g composed with f of g composed with f of 0 equals 3. Let's try part C. F composed with g of negative 1. The composition is substituting one function inside of another function, and this time f is written first, so f is our outside function, and g is our inside function. We'll first work out what g of -1 is. So our x value is -1. I want to go up to the graph of g to get a y value of 4. So that's g of -1 is 4. And now we can work out what f of 4 is. We have an x value of 4. I'm on the graph of f. That's a y value of 0. So f of 4 is 0, and f composed with g of -1 is 0. Last one, f composed with g of 4. F is the outside function, g is the inside function. And we'll find g of 4. So we start off with an x value of 4, go up to the graph of g to get a y value of 3. So g of 4 is 3. Now we can find f of 3. Go to an x value of 3, go to the graph of f, and we get a y value of -1. F of 3 is -1. F composed with g of 4 is -1. I just noticed you can't see those final answers, so let me write them out here. F of 4 is 0, and f of 3 is 1. -1. Given f of x equals 5x squared minus 4, and g of x equals 4 minus 1/2 x squared, find the following expressions. F composed with g of 4, g composed with f of 2, f composed with f of 1, g composed with g of 0. So we'll start with f composed with g of 4. So first I want to use the meaning of composition to rewrite this expression. Composition is substituting one function inside of another function. So that would be f being the outside function and g being the inside function. So now these symbols tell me exactly what to do. I'm going to work on the inside first, which says g of 4. So I want to substitute an x value of 4 into the function named g. So the function g is 4 minus 1/2. In place of that x, I make a 4 squared. I'm going to follow order of operations to simplify this and do the exponent first. 4 squared is 16. Half of 16 is 8, and 4 minus 8 would be -4. Now these symbols tell me what to do next. It says f of -4. So in place of x, I'll substitute a -4 into the function f. That would be 5 times -4 squared minus 4. It's 5 times 16 minus 4. 5 times 16 is 80. And 80 minus 4 would be 76. So f composed with g of 4 is 76. Let's try the next one. G composed with f of 2. So first I'm going to rewrite. G is our outside function and f is our inside function. Composition is substituting one function inside of the other function. So let's find f of 2. So that's 5 times 2 squared minus 4. Following order of operations, I'll apply the exponent first. So 2 squared is 4. Then I'll do multiplication. 5 times 4 is 20. And 20 minus 4 is 16. Now these symbols tell me what to do next. G of 16. So I'm going to let x be 16 in the function g. That's 4 minus 1/2 times 16 squared. So following order of operations, I'll do 16 squared. 16 squared is 256. Half of 256 is 128, and 4 minus 128 is negative 124. Let's work on the next one. F composed with f of 1. So this is going to be f on the outside and f on the inside. I'm going to work out what f of 1 is. I'm substituting 1 in for x in the function f. 5 times 1 squared minus 4. Applying the exponent first, 1 squared is 1. 5 times 1 is 5. And 5 minus 4 is 1. Then we want to work out f of 1. That's 5 times 1 squared minus 4. 5 times 1 minus 4. 5 times 1 is 5. And 5 minus 4 is 1. Then finally we'll work out g composed with g of 0. G is our outside function and g is our inside function. We'll substitute a 0 in for x in the function g. 4 minus 1/2 times 0 squared. 4 minus 1/2 times 0. 4 minus 0 would give me 4. Then I want to find g of 4. That's 4 minus 1/2 times 4 squared. 4 minus 1/2 times 16. Half of 16 is 8, and 4 minus 8 would be negative 4.